Today, AI writes poems, drives cars, and even makes YouTube videos. But back in the 90s, AI was awkward, unnoticed, and quietly discovering something revolutionary: how to learn from data. This is the story of how machine learning emerged from the shadows thanks to games, math, and one historic chess match that changed everything. It is a quiet story, not a sudden reveal, but a long set of small revolutions. We'll follow how ideas moved from rules to probabilities, and how that shift seeded the AI we know today. Start small, think data, not instruction, methods, not myths, where the quiet work of a few became the foundation for a global shift. First, the era of rules. Then, the idea that machines could instead learn from examples. Imagine teaching a computer to recognize a cat by listing fur, whiskers, ears, tail, line by line. It worked, until it didn't. Because the real world is messy. Too many exceptions, too many unknowns. What if, instead of giving the computer rules, we gave it data? What if the machine could figure things out for itself? Before the 1990s, artificial intelligence followed one simple idea: tell the machine exactly what to do. It was all hand-coded rules. If this, then that. Want to teach a computer to recognize a cat? You'd have to define fur, whiskers, ears, tails, line by line. It was like trying to explain a cat to a machine using legal code. It worked, until it didn't. That's when researchers started asking a new question. What if, instead of giving the computer rules, we gave it data? What if the machine could figure things out for itself? Learning from data is like planting seeds. Models grow patterns from examples, not rules. This shift, from instructing to exposing, set the stage for machine learning. Researchers built new algorithms to do this, ways to find patterns inside data. In the next section, we'll look at the specific methods that emerged in the 90s. They weren't flashy, they were statistical. Decision trees, k-nearest neighbors, support vector machines, simple ideas that scaled when data arrived. And so, in the quiet corners of research labs, a new approach began to form: machine learning. It wasn't based on hard-coded logic, it was based on statistics, probabilities, and patterns. Decision trees split data by choices, a tree of decisions that leads to a prediction. They are intuitive and easy to interpret. K-nearest neighbors simply looks at similar examples and votes on what's likely. Simple math, useful results. Support vector machines searched for the best boundary between categories, elegant and effective in many cases, not flashy but often powerful. Machine learning started powering basic tools like spam filters, handwriting recognition, and stock predictions. Was it flashy? Not really, but it was powerful. These methods were the foundation of modern AI. While the rest of the world was watching Friends and playing Pokémon on Game Boys, computer scientists were tweaking formulas to classify emails and identify digits. Next, a public moment that made AI visible. Then came 1997. IBM built a supercomputer called Deep Blue. Its mission? To defeat the world chess champion, Garry Kasparov. At the time, this was unthinkable. Kasparov was considered unbeatable. But Deep Blue had one advantage. It could calculate over 200 million chess positions per second. It was built purely for brute force calculation. On May 11, 1997, Deep Blue won. Kasparov walked away shocked. There was no rematch. The moment made global headlines. It was the first time the public truly paid attention to AI. Suddenly, AI felt real to many people. Now let's be clear, Deep Blue wasn't using machine learning. It didn't learn or adapt, it brute forced every possibility. But to the world, it felt like AI had taken a huge leap. It was no longer science fiction. It had just defeated a world champion on live television. After the headlines faded, the quiet, less glamorous work continued. The slow engineering of systems that would scale with data. In the next decade, the internet would give machine learning the fuel it needed. After the chessboard was cleared, AI slipped out of the spotlight. But in the background, something even bigger was brewing. In the early 2000s, the internet exploded. More websites, more emails, more photos, more data than ever before. And machine learning? It finally had the fuel it needed. More data and more compute unlocked practical deployments. Google used it to improve search results. Amazon used it to recommend products. Netflix used it to suggest movies before you even knew you wanted them. Algorithms like support vector machines and naive Bayes quietly powered these systems behind the scenes. They weren't glamorous, but they worked. And all this time, the models that would one day power ChatGPT and image generators were just sitting in the background. Too slow, too expensive, too misunderstood. Machine learning was doing the heavy lifting. It became the brain behind the boring stuff: spam filters, ad targeting, speech recognition. While most people were busy uploading glittery GIFs to MySpace, AI was evolving behind the curtain. By the end of the 2000s, something important had happened. The models worked, and the world had the data to run them. By the end of the 2000s, the groundwork was complete. The models were proven, the data was everywhere, and the world was unknowingly running on AI. Most people didn't notice. There was no big reveal, but under the surface, AI had quietly matured. The next era, the deep learning boom of the 2010s, would take this silent revolution and make it impossible to ignore. From virtual assistants to generative models, everything we now call AI stands on the shoulders of this forgotten decade. No single moment made AI inevitable. It was the accumulation of many small wins. Mostly it was slow, patient progress, the kind that only looks boring in the moment. But it laid the technical and cultural foundation for what followed. So, no, the 1990s and 2000s didn't make AI famous, but they made it possible. Thanks to the rise of machine learning, we moved from rulebooks to pattern recognition, from code to data. And it all started with researchers chasing probabilities and a machine that dared to challenge a chess grandmaster. The 1990s and 2000s didn't make AI famous, but they made it possible. Small, patient work created the systems we now rely on. Want to know what happened next? Subscribe for the next episode to find out. Subscribe, hit the bell, and join us for the next episode. The revolution wasn't just a headline. It was a long accumulation of ideas, experiments, and data. See you in the next episode.